school. This is your next session of your class 10 mathematics 8th chapter real numbers. It is NCERT or CBSE syllabus. So look here children, in our last session of part 1 we have completed up to 3 problems. Right now we are going to see quickly 4th problem. What's your 4th problem? This is very important problem. Look here carefully. Use Euclid's division lemma. Do you remember children what is Euclid's division lemma? A is equal to BQ plus R, where what is your reminder? Reminder must be greater than or equal to 0 and less than B. That is your condition. To show that the square of any positive integer. So what we need to show here? Square of any positive integer is either of the form 3m or 3m plus 1. So here children, observe here, we need to consider a positive integer and that integer is in the form of either 3m or 3m plus 1. We need to show what is that? Square of the integer is in the form of 3m or 3m plus 1. We need to show. So here for some integer m. So observe here carefully. So what is this? 3m plus 1. Whatever you do the square of any positive integer, your answer should be in the form of 3m or 3m plus 1. So there is a hint given here children. What is the hint? Let x be any positive integer. So in this hint what we can see, consider x as a positive integer. Then it is of the form 3q plus 1, 3q plus 2. Observe here children, immediately if you remember any number you see with a q, immediately you should remember BQ. A is equal to BQ plus R, where the B value is 3. Like this you should remember. So you have to take 3 cases here, 3q, 3q plus 1 or 3q plus 2. So we have considered any positive integer and equated with these 3 values. Why we are equating? Do you know children? Understand it properly. In your question, you have 3m. Observe here carefully. M may be any integer. Right? So you forget about m. Immediately if I see there 3, in my mind, I fix it as b. B is equal to 3. Okay, what will be the reminders? If B3, R is equal to 0, 1, 2. So same thing, look here. A is equal to BQ plus 0. It will be 3Q. A is equal to BQ plus 1. That will be 3Q plus 1. A is equal to BQ plus 2. That will be 3Q plus 2. There is no other reminder to substitute in your Euclid's division lemma. This is the thing you need to understand by seeing the question. So only one thing you observe here children. What is the number multiplied with any integer you see there? That number you fix with B. Reminders you can guess and you can apply in your Euclid's division lemma. Okay children, let's start our problem. So whatever you do, these 3 cases, if you take with a positive integer, A is equal to 1 set if you take. And what you need to do here children? Square of it. Suppose if I take A is equal to 3q, do whole square on both sides. Make sure your answer should be in the form of either 3m or 3m plus 1. So let's start our solution here children. Let A be any positive integer. Then it is in the form of 3q plus 1, 3q plus 2. How I have taken 3q understood no children? Forget about m. So imagine here, if b is equal to 3, what are all the reminders? 0, 1, 2. Then substitute in Euclid's division lemma, that is A is equal to BQ plus R. What you are going to get? A is equal to 3q plus 0, that is 3q, and A is equal to 3q plus 1. That will be as it is, and one more case, A is equal to 3q plus 2. See, these are the 3 reminders you have substituted in your Euclid's division lemma to get the 3 cases here. So let's start here. Case 1. A is a positive integer, right? So for A, if A is equal to 3q, you take. This is your first case. What's your second case? A is equal to 3q plus 1. And what's your third case here? So let me write here. A is equal to 3q plus 2. Third case, right? This is all rough work. Okay. So now look here. So we have taken A is equal to 3q. What I need to do? Read the question again. Square of any positive integer. A is a positive integer and I have equated it with 3q. So square of this you have to convert in the form of either 3m or 3m plus 1. So let's start. SOBS. Do you know what is this full form, children? Squaring on both sides. Okay. Squaring on both sides. A whole square is equal to 3q whole square. A whole square will be A square. 3q whole square. 3 3s are 9. Q square. So now I didn't get any 3m. But understand here I can take 3 common. So now what I need to do here? A square is equal to 3 into 3q square. Let us consider m is equal to 3q square. So if I take m value 3q square, then what does it become, children? A square is equal to 3m. Square of any positive integer is of the form 3m. So now instead of 3q square, I have taken it as m. Assume m is equal to 3q square. So now what you got? A square is equal to 3m. Observe the question there. Square of any positive integer is of the form 3m. So let's see the second case here. Case 2. A is equal to 3q plus 1. What we need to do? Squaring on both sides. That is A whole square. Okay. A whole square is equal to 3q plus 1 whole square. Children, do you remember this? Which form it is? A plus B whole square, right? So now A square is equal to. So let me write your formula here again. A plus B whole square is equal to A square plus B square plus 2AB. Now apply this formula here. A value is 3q, B value is 1. A square plus B square plus 2AB. See, this dot indicates into. So now 3q whole square, how much? 3 3s are 9. Q into Q will be Q square plus 1 1s are 1 plus 3 2s are 6, 6 1s are 6 Q. So now look here, children, what I need to take here common. So let me write these two side by side. 9q square plus 6q plus 1. So now in these two, 3 is common. Yes or no? 3 is common. 3q square plus 3 2s are 6. 2q plus 1. So why did I take only these two terms common, children? In order to convert my square of a positive integer in the form of 3m plus 1. So now if I assume m is equal to 3q square plus 2q here, then what you are going to get here? A square is equal to 3m plus 1. This is your second case. So here, children, don't be confused. In your first case, you have written m is equal to 3q square. This case is different, okay? Then coming to your second case, you have assumed here m is equal to 3q square plus 2q. And don't compare here m is different and here m is different. Okay, this case is different and this case is different. Okay, we are assuming that is equal to m. Whatever we square any positive integer, it will be in the form of 3m plus 1. So let's see the last case here. That is a is equal to 3q plus 2. What you need to do here? Squaring on both sides. A whole square is a square, and next 3q plus 2 whole square. What is 3q plus 2 whole square, children? Again same format. A plus b whole square. That will be a square plus 2ab a plus b square. What is a plus b whole square? A square plus 2ab plus b square, or a square plus b square plus 2ab also you can write. So now 3q whole square, 9q square plus 3 2s are 6, 6 2s are 12q plus 2 2s are 4. Now observe here, children. Now most of the people will be confused here. Oh, I cannot take out 3 common. Only these two I can take out 3 common. Then 3m plus 4 getting. So no, not like that. 4, how can you rewrite? Think here, children. 4 we can write in the form of 9q square plus 12q plus 3 plus 1. 3 plus 1 is 4, right? Split the 4 in the form of 3 plus 1. So now in these 3 take out common. 3q square plus 4q plus 1 plus 1. Assume that this as m. That means 3m plus 1. A square is equal to 3m plus 1 is your answer. So here, observe here carefully, children. Once again, I repeat. So, when you see in your question anything like this, 3m, 5m. So, you imagine 5m. 5m means what you need to do? B value 5, R will be 0, 1, 2, 3, 4. Okay. So, substitute what happens there? 5q plus 1, 5q plus 2, 5q plus 3, 5q plus 4. Okay. How many cases you got? See there. Same manner, any number it might be, right? So don't by heart the problem, try to understand. So 3m plus 1 there. So what did I do? 3 is b, r value will be 0, 1, 2. So I have taken here 3 cases. But if I take a as a positive integer, the square of it is your question. Read the question carefully. The square of any positive integer will be in the form of either 3m or 3m plus 1. Same as it is I have taken, children. Let me consider the 3 cases here. A equal to 3q, a equal to 3q plus 1. Have you got? If r 0 in Euclid's division lemma. If r1 in Euclid's division lemma, what you are getting? A equal to 3q plus 1, a equal to 3q plus 2. So in the 3 cases, what we have done? Square of the integer set. So squaring on both sides, apply whole square and try to get your answer in the form of either 3m or 3m plus 1 only we got. Okay, with this I end this problem. Look here, children, 5th problem. This is also similar type of problem, but children feel little difficult of this problem also, but I'll make you very easy for you. Look here, use Euclid's division lemma. A is equal to bq plus r to show that the cube of, cube do you know, children? Power 3, right? Cube of any positive integer is of the form 9m plus 1 or 9m plus 8. So, 1 second, let's stop here. What is this, children? Here, 9m plus 1, 9m plus 8. Immediately, what did I ask you to remember here? Yes, I have seen here 9. Okay, I have seen here 9 means what you have to imagine. B is equal to 9, R is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Oh my God, many cases you need to solve here. Right? So, observe the number and Euclid's division lemma, you imagine that A is a positive integer. A is equal to, if you apply BQ plus R, yeah, B value is 9. Okay, so observe here, children, cube when we do, we get greater numbers, right? So in order to reduce our problem, minimize your problem, no problem. So what you need to take here? Multiple of 9. Let's take 3. Okay, 3 is also a multiple of 9, right? 3 3s are 9 you may get. So if you take 3 also, same cases you are going to get. So what do you do, children, here? B is equal to 3. If you take B is equal to 3, what are all the reminders you can guess here? 0, 1, 2, okay, no 3 here. Okay, when you are writing your reminders, do you remember the condition here? And the reminders, how it will be? Less than B value and maybe equal to or greater than 0. So your reminders will be 0, 1, 2. When you consider 3, when you consider 9, children, if you are interested, you can do with 9 also. 9 means it takes a little bit lengthy and you are going to get a big problem. Anyway is correct. So now let's start our problem. What's your problem? You have to consider a positive integer and cube of the positive integer. Apply Euclid's division lemma. Cube of that integer, you are going to get the answer in the form of 9m plus 1 or 9m plus 8. Same manner how we have done 3m plus 1, no? Like that only we are going to do here. So now let's start here. Let a be any positive integer. So let us consider 3 children here. If you want, you can take 9 also. I am saying there is no rule like that. If B is equal to 3, what are the reminders here? 0, 1, 2. You can guess your reminders, children. Okay. So now what's your Euclid's division lemma? A is equal to B cube plus R, where A and B are any two positive integers, Q and R are unique integers, there exist, and the condition is R is greater than or equal to 0 and less than B. So now, how many cases you are going to get here? 3 cases. So look here, if R is equal to 0, first case, observe here, R0, what happens? B3, R0, substitute in Euclid's division lemma. A is equal to 3Q plus 0. That is, A is equal to 3Q. Okay. Similarly, let's write here second case. What's your second case? If R is equal to 1, A is equal to B value is 3. Apply in Euclid's division lemma. A is equal to 3Q plus 1. And finally, our third case. What's your third case here, children? If R is equal to 2 and B is equal to 3. Apply in Euclid's division lemma. A is equal to 3Q plus 2. See here, children, I have written 3 cases for you now. Okay, if you take 9, 0, 1, 2, 3, 4, 5, 6, 7, 8. These many cases you need to solve in same procedure. Now, what's your next step? Okay, look there, cube of any positive integer. Here is a positive integer. So, cubing on both sides. COBS indicates cubing on both sides. Let's cube here. A cube is equal to 3Q whole cube. Do you know what I mean by cube, children? Multiplying the same number 3 times. A cube is a cube and this, look here, 3 if it is multiplied for 3 times, what happens? 3 3s are 9, 9 3s are 27. 27 Q cube. So now next step, observe here. What you need to show here? Your answers of cubing should be in the form of multiples of 9m plus 1 or 9m plus 8 you need to get. What you need to get your answer? You need to show your answer or rewrite your answer in this format. If possible only you write, but don't try to manage. So now look here, 9 is common. You can take 9 common now. If you take 9 common, 9 3s are 27, 3Q cube. So now if I assume, let me assume this as m. Therefore, what I can say, a cube is equal to 9m. Yes, your answer is in the form of 9m. Let's see the next case here. A is equal to 3q plus 1. Again, same format here. Cubing on both sides. What do you get here? A cube is equal to 3q plus 1 whole cube. By the way, what is a plus 1 whole cube formula? Do you remember here, children? So look here. A plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. What's a cube? A plus b whole cube, children? A cube plus b cube plus 3ab into a plus b. Let's substitute that formula here. A cube is equal to, A value was 3 cube, B value was 1. That is 3q whole cube plus B cube, that is 1 cube, plus 3ab, 3 into 3q into 1 into 3q plus 1. Okay, now simplify here. 3q whole cube, what it will be? 3 3s are 9, 9 3s are 27. 27q cube plus 1 cube is 1 plus 3 3s are 9. 9 into 1, 9. 9q into 3q plus 1. Still, it's not complete. Still, we need to do here. 27q cube plus 1 plus 9 3s are 27. Q into q, q square plus 9q. Okay, so you have one extra here. This one, write it here. Right? So next step. 27q cube plus 27q square plus 9q plus 1. So now observe here, children, in these three, anything you can take out common? Yes, 9 you can take out common. So let's take out common here. 9. 3q cube plus, see here 27 means 3q square plus q plus 1. Now assume, see here children, assume this one as m. So what you are going to get here? 9m plus 1. A cube is equal to 9m plus 1. See here, positive integer a, its cube is in the form of 9m plus 1. So your last case for this problem here, what is that? If r is equal to 2, b is equal to 3, what you are going to get? A is equal to 3q plus 2. Now what's your first step here, children? Cubing on both sides. Cubing on both sides here. So now again, a whole cube, 3q plus 2 whole cube. Okay, same pattern here. Apply the cube formula here. A cube is equal to, what is a plus b whole cube? A cube plus b cube plus 3ab into a plus b. Okay, that will be 3 3s are 9, 9 3s are 27, 27q cube plus 3 times multiply, 2 2s are 4, 4 2s are 8 plus 3 3s are 9, 9 2s are 18q into 3q plus 2. Now next step here, children, observe carefully. 27q cube plus, so 8 as it is, plus 18 3s are how much here? 54 q square plus 18 2s are 36 q. Now write the numbers aside here. 27q cube, okay, can you see here carefully, plus 54q square plus 36 cube plus 8. Okay. So now 8. Do you remember here? Yes, I think your answer must be in the form of 9m plus 8. So now in these 3, you need to take out 9 common. So now 9 if you take out common, 9 3s are 3 cube. Okay, next 9 6 are 54. Then again 9. Okay, stop. Okay, next 9 4s are 36. So now observe here, children. Let me consider this full set as m. Finally 9m plus 8. That is 8 cube is equal to 9m plus 8. See here, children, if you take 9 also same manner you can write. So whatever you get, your cubing of the positive integer answers will be in the form of either 9m plus 1 or 9m plus 8. So look here, children, once again let's have a recap. These two problems are very important for you. Try to practice 2 times now itself. Okay, then you never forget the problems. So now observe in the question what you have here. Main concentration here only. What the number there? You have to assume it as B. Yes, B is 9. R will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So what's the condition? In Euclid's division lemma, if A is equal to B cube plus R, where its radius is greater than or equal to 0 and less than B. So now I have considered a positive integer as A. If A is a positive integer, then in Euclid's division lemma, if I take a multiple of 9, I am not going to take here 9, I have taken here 3. So children here, why must have taken 3? You may get it out. You may take 9 or you may take 3 also. If we take 9, your calculation part will be lengthy. So in order to reduce, I have taken 3. If you are interested, you can take 9 itself. So B equal to 3. If B 3, R will be 0, 1, 2. So how many cases you will be getting here? 3 cases you are going to get. Now take your Euclid's division lemma and substitute R 0. So now first case what you have taken here? B equal to 3, R equal to 0. You have applied in Euclid's division lemma, cubing on both sides. So you have taken finally 9 common and remaining part you have assumed it as m. Okay, every case m will be different, right? So now in the second case, if r equal to 1, b equal to 3. So now take a is equal to 3 cube plus 1, cubing on both sides, apply a cube plus b cube plus 3ab into a plus b formula. What you get your answer? Take out 9 common, then make it 9m plus 1. Similarly 9m plus 8. This is the way we do this type of problems. So with this, we are going to end our session today, children. Tomorrow we are going to start with your next exercise. Thank you all.